The Ethereum community is excited about the Shapela upgrade, which, along with other improvements, will also enable ETH withdrawal for stakers. But if you are a curious cat interested in learning about the next big thing in Ethereum, you are at the right place. Continue listening for the world of blobs. Welcome to PEEPanEIP episode 104. I am Pooja Ranjan with two special guests with me to talk on the Anchor EIP for Dencun upgrade. This EIP has an interesting history. For people who aren't aware, about 13 months ago in ETH Denver, a few ELCL devs along with Specs help from Shivey, Dankrad, and Vitalik hacked together a full data blob transaction prototype called mini Danksharding. EIP-4844 was documented a few days later on 25th February 2022. According to a tweet thread, data blobs are the first milestone towards full Ethereum sharding, enabling rollups like optimistic PBC to grow 100 times in capacity. In the next hour, we will learn about EIP-4844, the concept of blobs, and how it will improve scalability. To provide an overview of progress and testing so far, we are joined by Terence and Kasey. Welcome to PEEPanEIP, Terence and Kasey.
Thanks for having us.
Thank you for joining. May we begin with a quick introduction of yourself and how you joined the Ethereum space before we dive deep into the world of blobs?
Sure, I can go first. So back in 2018, I was really bored. I was working at a networking company doing machine learning. And then one day I stumbled upon a Reddit thread from Vitalik asking to implement scalability and then working on sharding. And back then, sharding wasn't like sharding like today. Sharding was actually sharding through smart contract, which you need to deposit 1,500 ETH. And yeah, so it wasn't like, we weren't sure whether that was the way to go. So long story short, proof of stake happening in parallel. So we ended up working on proof of stake just because that seems more urgent. And then fast forward 4 years, we launched the Beacon chain, and then we did the merge. And now we're back to square one. We're back to working on sharding, but this time with a different type of sharding. So yeah, happy to be here.
I've been working in software for about 20 years on at startups doing like data backends of different kinds, and didn't get into anything blockchain related until 2020 when I started reading about the fact that Ethereum was going to finally be getting rid of proof of work, and that's kind of what motivated me and got me excited to read about how that was going to take place and what the concepts were. And I was thinking about running a validator. I joined Prysm's Discord. And then one day, I think it was Raul put out a message saying that they were hiring, and I looked at the job description. It was a bunch of like technologies that I'd been working with a lot. And so I kind of YOLO'd my resume and got an interview, and was lucky enough to join the team about 2 years ago. And I've been falling down the rabbit hole ever since.
Kasey is our residential Go land master. Like, he started working on Go before Go was cool. So we typically go to him for all the Go questions and stuff like that. So yeah.
That's awesome. Very interesting. Well, thank you for the introduction. I understand we do have a presentation here. So without further ado, let's peep in.
Okay, sure. Yeah, I can start. And I want this to be open forum. So if anyone wants to jump in, say something, just say something. Feel free to interrupt me. Okay, so I will start. So yeah, so why EIP-4844? That's typically the first question. And then the first 10 slides are pretty, I would say, introductory. So just bear with me, and I will go to them very quick. So why 4844? Well, because of the scalability trilemma that Ethereum community has been facing for the last 10 years, right? So we want something decentralized, we want something secure, that's part of our DNA. But on the other side of the spectrum, we also want something that's scalable. But we would never sacrifice decentralization and security for scalability, because that's not what we do, right? You have like chains that's very high TPS, but with the trade-off that's less decentralized and secure, and that's not what we want. But how do we like compete with like Visa, for example, that does like many more in terms of scalability, transaction TPS than what we do, right? We cannot compete to that, unfortunately. Ethereum today does like probably 10 average transactions per second, probably more transfers, more ERC20 transfers, probably a few exotic transactions here and there. So we cannot increase the block space, we cannot increase the DPS, right? So we, as a layer one, we really cannot compete with this like global internet of value, right? So so then here comes the rollup-centric roadmap, which Vitalik proposed. So Vitalik proposed a couple of years back that Ben Edgerton actually has a good phrase for it. So I'm just quoting him. Essentially, he said that we're putting rollup puts skyscrapers on Ethereum, right? If you look at the picture on the right, you see Manhattan, some of the most expensive real estate in the world today, right? But economic forces basically brings them together to build tall buildings to essentially pack more things. So you have more density per square feet, right? Because of this type of economic force. And then you can think of Ethereum like Manhattan, essentially, right? Layer one is pretty expensive. It does 10 TPS per second. Then you have DeFi, like NFT, ICO, they all share this layer one. Then of course, the gas will rise. People will pay more than what they intend to pay, and people will get priced out. So what happens with layer twos? So on layer twos, essentially layer two uses layer one, uses cold data, and then it separates execution. It separates execution by posting data on the chain. Because of that, you can build more, you can pack more things to it because it's compressed. It's optimized for throughput and user experience. And then, so you can see that picture is kind of like a skyscraper, right? Because now you can have more apps on it, but then the apps are more focused in a way, versus you still have apps on layer one that's more optimized for security. And then today layer two uses cold data. That's what we know. And with 4844 layer two, we're use BLOBDATA, right? So the idea here is that, okay, we're gonna fit layer two a different type of data. Instead of using cold data, we use BLOBDATA. And by using BLOBDATA, we're hoping that layer two can thrive even more, that have more scalability on top. And the question is, why is that, right? So what is this advantage of BLOBDATA? Why is BLOBDATA better for layer two than cold data? So we're gonna explore that in the next few slides. So the idea that we want people to understand is that the blob data doesn't increase the block size. So we're actually not sacrificing decentralization at all, right? We're essentially bolting the blob onto the block through a commitment scheme, which I will get more into later. But all you have to know is that we're not increasing the block size here. We're not sacrificing decentralization. We're just adding this new commitment onto the block. And the commitment points to the blob. So block versus blob, what is the difference, right? So block and blob are seen by all the nodes. So that means there is a bandwidth constraint. So they all have to download both data. In terms of size, the block size, each single block has 1 megabyte theoretical limit. It gets very expensive once you reach that limit. Versus the blob has 128 kilobyte target, 256 kilobyte max. And then in terms of storage, the block, the execution at user level, the NFT, like Uniswap related data are stored on the execution client, versus the blob are stored on the consistent client. So that's the difference. In terms of EVM access, longevity, cost, those three are the biggest difference, and that's what makes blob much cheaper. So so for block, there's EVM access, you can access the block. But for blob, there's no EVM access. You cannot access the blob data, but you can access the commitment. That's all you need. And then in terms of longevity, block are stored forever. That's why it's expensive. Versus blob, it can be pruned up to 18 days, right? So in terms of the cost, for block, if you want to store code data on a block, it's 16 bytes per guess. Versus blob space is fairly cheap, which we can run some numbers later. And then now the question is, okay, like, what good is it useful if the blob, if you cannot access the blob through EVM, where you can only access the proof, you cannot access all the data. That's something we'll get into the next few slides. So what is a blob transaction? So a blob transaction is, think of just like random raw data, like OPET data. You submit it to the execution client mempool, and then it's gossip among all the execution client. And then the blob transaction consists of new transaction type 0x05. It has all the usual data fields, and then it has this new field. It's called blob version hash. So this is the magic, right? This is the commitment scheme that I talked about earlier, that to ensure that whatever commits on the blob also basically like align with each other. So your blob aligns commits to the block. So that's how the commitment works, by having this new blob version hash. Also, it's worth mentioning the blob transaction is encoded in SSZ. It's a new, more modern hashing Marshall algorithm that's developed on the consensus layer. But we're gonna start bringing that to the execution layer as well to revamp RLP. So that's something very interesting as well. This is the first time we're doing this. So a question here is that you might ask, right, how does the layer 2 use the blob transaction? So this is a very oversimplified version of it. So as a layer 2, you're a sequencer, you get the transactions from your layer 2 users, and then you essentially compress them in a batch. And then today you use CALLDATA, but in the future you use BLOBDATA. And then you essentially compress them, you submit that blob transaction, plus some regular transaction if you want to like some EVM changes you have to do to the execution client mempool. And then the execution layer client will gossip that among each other, so everyone has it, okay? And then as a validator, right, say you're proposing the next block, typically you will get the block, you will sign the block, but now you have to do more. You also have to get a blob bundle. If you're an honest validator, if you're a rational validator, you would do that. So you get the blob bundle from the execution layer client mempool, you sign that, you sign the blobs, and then you gossip the blobs among all your consensus layer client peers. So all the peers have the blobs, they verify it, blah, blah, happy. And then they pass a blob transaction to their local execution layer client to validate it. Because if that's invalid, then the block will become invalid as well. And sometimes later, the other layer 2 nodes, the other layer 2 validators on the same layer 2 chain will also verify those blobs are indeed correct, basically. So they'll basically read the blob, not through this get blob beacon API, so you can get the blobs from the consensus layer peer. So I'm gonna quickly, in the next few slides, I'm gonna quickly go through like how are we thinking about EIP-4844 Prysm, just because yeah, how are we thinking about that, right? So I think it's worth noting that like what happens at every upgrade. So at every upgrade, we always have to change these things. We have to change our P2P stack because the way we gossip, we'll gossip new object, like beacon block will change. There's some object that will change typically at hard force. Therefore, your P2P will change. Then because of that, your state transition will also change as well, because at every upgrade, for example, withdraw, you will add new state transition rules and stuff like that. And then your state will always be different. So your state transition will change. And then your engine API will likely change if there is changes on the EL side. So if your EL changes, then you have to propagate those changes to the CL. So engine API will change. And last but not least, your validator will change because you likely will sign different things. And then your beacon API will change because beacon API is the gateway between users and then the node, right? So beacon API will provide new endpoints. So based on these principles, like these 5 changes are typically have to change on every upgrade and hard fork. So for 4844, the beacon API changes will add new endpoints to sign the blob and to download the blob, right? And then there's this new paradigm that we're talking about signing blind block. So this is kind of independent with 4844, but people are constantly making improvement to the beacon API endpoint. So that's good to see. And then in the backend, we're also thinking about like this Prysm Validator 2.0, I call, because currently we use Prysm API, but it would be nice to switch that to the Beacon API, use the official API. So we're thinking that how do we like intersect with that effort as well? That's what we're thinking. On the validator side, now instead of signing block, we're also signing blob as well. And there's no slashing equivocation for signing duplicated blob. You wouldn't do that because if you do that, there's a risk of your block get orphaned because of people receiving like incorrect blob that you signed, then your block will not get imported later. And then, but not having slashing equivocation does make things a lot easier to implement. And then in terms of validator, what we care is of a latency because we don't want the block to be reorg. So it's important to have good latency on that. And then another thing to think about, I don't have an answer today, so what does it mean for like this distributed validator technology like OBO, for example, right? Because they have this like threshold key signing mechanism. So now they have to apply that for all the blobs. There's some very interesting and open questions there I encourage people to think of. So crypto library, we're switching most of stuff to KZG, and then there's an update starting in April 17. So we're finalizing the polynomial commitment related interfaces. On the back end, we want to improve security UX, right? For example, open questions like where does the user host the trusted set of a file and stuff like that. So that's very interesting, which we haven't done much before. That's something that's worth thinking about. And then the block and blobs import. So here's the thing, right? We cannot import the block unless you have the blobs. So essentially, it's like, what do we do with it, right? So typically client will queue them in the P2P package until they have everything before they import them. Now the question is, okay, when you're queuing them, like when do you become nervous? When do you request the missing object when you know it's missing? And then another question is how long to keep the objects for if you never get the complete pieces of them, right? There's some DOS vectors involved. So this requires a really, really good and clean design. And then it plays a very critical role in validator performance. So I made this like diagram, just all the possible scenarios when you have objects without each other. I mean, I'm not gonna go through them right now, but I'll share the slides after. You're just happy to take a look. In terms of forward syncing, right? So syncing remains the same basically, but now you have to also sync the blob as well. So client may get stuck if you don't have a blob for some block, for example, and then you have to design peer scoring, array delimiter, and stuff like that. So that's another things to think about. And then in terms of backfilling, so unfortunately, Prysm doesn't do backfilling today. It's a shame, but we'll do it. Now, I think now we have to do it because now we have to backfill blob as well. So we need to implement backfilling. So that's very exciting, something to watch out for. And then let's find out this in terms of UX, right? We have this Prysmctl. It's a utility that we use for a lot of things, for downloading the state, for checkpoint syncing, right? So we would love to extend this Prysmctl to do more things with blobs. So you can download blobs, you can verify blob transactions. Maybe you can send blob, maybe not. I mean, still thinking about whether that's like something that we want to support. But thinking about what to support, yeah, with those tools are useful. So where are we today? So today we have multiple devnets. So far, it's just like you said, this thing started at Denver last year. So like quietly, people actually have been working on this for a year. It's crazy to think about. So there has been many spec iterations. Right now we are on devnet 4, we're moving to devnet 5. Devnet 5 has these new radical designs that were decouple the blobs and blob all together. And then the EL client team are working on the TS mempool hardening. So hopefully we'll do the V5 soon. And let's see. So where are we today? Sorry, I skipped this slide. So we have consensus spec, execution spec, and engine API spec. They're all pretty well defined, I would say. A lot of it is just on client implementation to catch up to the spec. So there are, actually this is incorrect. Nimbus is also ready. So I'm gonna remove that, yeah. So we have all the client implementations as far as I know, they are all ready. they are all working towards DevNet 5. And then in terms of tooling, we have this wonderful forks. We have this wonderful team that's working on Blob scan 4844. That's another area to watch out for. I think that's very useful to have some sort of tooling that you can watch the blobs. And KZG ceremony, I think this just ended as well. So this is also slightly incorrect. This is outdated. KZG ceremony has been done, and yeah, kudos to everyone participating on that. That's very exciting. So yeah, I think that's it from the slides perspective. So yeah, we can move to open QA and stuff and just open discussion. So I want to correct myself, the KZG special, this is KZG, there's two phases. There's one just more general audience. That part ended, but now this KZG special controls are still happening. So thank you, Justin, for the correction.
Thank you so much for the presentation. Like, it is really interesting to look into from the beginning, like how we started conceiving the concept of blob and all about it, and till today's progress. Okay, so yeah, I have a quick question related to KZG. Can you maybe briefly talk about the importance of it for 4844, why we are doing that to have a trusted setup here?
The way for KZG to work is that you need trusted setup. You need some sort of randomness that such that like no one knows the final answers, because if someone knows the final answers, like the entropy, people can ideally like craft like signatures in a way that just trick all the nodes to do like really bad things, right? So how do we generate that trusted setup? And then we want it to be as decentralized as possible, like ideally as clean as possible, that when people generate some entropy, people threw away the entropy after. And there has been many creative ways on people doing that, such as making like cat toys and then stuff like that. So yeah, it is very important.
Sorry, just quickly, Pooja, was your question about the setup or why KZG is used for 4844?
So why for 4844 would be the first one, and why do we need a trusted setup in the first place for there?
Okay, so I think like, yeah, so for the trusted setup, so basically the KZG scheme, what it requires is a so-called structured reference string. And what that means, it's randomness that has internal correlation. And the way that works, so some say cryptographic schemes just need randomness as an input. And that's easy. You just like say like, oh yeah, we all agree that we take the output of this hash function from this input as our randomness. Done, you're done. But here you need correlated randomness. And what that means is basically in elliptic curves, there's a way where you can put a secret into a black box, basically an elliptic curve element. So that's, for example, your public key. When you have your private key, and when you generate a public key using elliptic curve, you basically put your private key into this black box, and you can't look inside, but you can still use it in some ways, for example, to encrypt messages to you. And what we need here is that we take the powers of one number and put all of these powers into this black box. So that's the correlation. That's how they are like related. And so like for this, you basically, yeah, you need to do this in such a way that nobody knows the secret. And that's what the trusted setup is. So we compute the series of powers inside the elliptic curve in such a way that nobody, no individual, and even no like large group of individuals can know the secret unless every single person who participated in this trusted setup cheats and makes their randomness available. Yeah, and the reason, like, I guess, like the other question is, why do we need this KZG scheme? Like, why can't we just use something that would not need such a trusted setup? Because there are many like other commitment schemes. For example, Merkle trees do not need trusted setups. And the reason for that is that in fact we don't actually require this for what we want to do with 4844. Like implementing 4844 would be possible with a different commitment scheme. But what we want is that we can seamlessly upgrade this to full sharding, which requires data availability sampling. And for that, we need a polynomial commitment scheme. And KZG is the best one that we have available.
Pretty interesting. Thank you so much, Dankrad. Justin, please go ahead with your question.
Hi, Terence. I have a question. So I'm coming at this from an execution developer's perspective, where we use RLP for everything all the time, right? And working on 4844, we're introducing some SSZ. So I have kind of a two-part question for you. One, my understanding is that we are fairly minimal in the requirements for SSZ with regard to 4844. And that's a good thing, and we like that. And it's going to give us the opportunity to add more SSZ later on. Follow-up question, sell me on why I should be excited about SSZ when I look at my code base and it's just RLP all over the place. Like, can you get me excited for the upcoming work that I'm gonna do here? Because I think in my heart of hearts, I'm like, I like SSZ on paper, it's good. Can you kind of maybe elaborate on that a little bit and sell me on that migration?
Kasey, you want to take that since you work on SSD the most, or I can take you too?
Yeah. One nice property of SSZ is just from like a hashing perspective, is the kind of recursive nature of it. So you can tell me if RLP already does this, where you'll see in the consensus spec there are a lot of types that have like a header variant. So which kind of allows you to substitute an entire nested data structure for the root of that data structure. And then when you compute the root of the outer container, you wind up with the same value as if you had inlined the entire data. So that's neat to me, but I don't know if that property was also present in RLP.
It's not, no, there's no native Merkleization or hashing or anything like that. I mean, RLP is intentionally very, primitive. It's recursive lists.
So basically what SSZ does well is efficient Merkle proofs. So like if I want element X from this data structure, it's very easy to create a Merkle proof for exactly that point. I think that's hard in RLP because you would need to iterate through all the elements before, so it wouldn't be efficient as far as I understand, because each element comes with a length, right?
Sure. So am I right in my assumption that, or my impression rather, that there is a minimal requirement of SSZ 48444? Like we're just using a little bit of it from the execution layers perspective, because I know that it's been everywhere on the consensus layer like forever.
Are we just computing the root of the byte encoded transaction, or is there an entire transaction structure? I can't remember how it looks on the EL. So I guess the answer to your question would be like, what's how many of the types of the SSZ spec are you using? Otherwise, I think you'd implement the full marshalling, unmarshalling, and hash tree root.
Okay.
I guess the other question is like, I think SSZ itself is just fairly simple. Like,
sure.
Yes, you are using, like, it's not complicated, but the whole thing is also just not very complicated.
It's an evolution,
similar to RLP as well, which I think is also not very complicated. The problem is just that it's not suited for efficient Merkle proofs. Cool.
Thank you.
Hi. I've heard on like some of the core dev call that like after 4844 home stakers or stakers who have sort of lower bandwidth and equipment requirements wouldn't be able to produce blocks anymore because I think computing KZG commitments to the blobs would be too much. I just wanted to check if that's the correct understanding, and if that is, like, what do the core devs think about the risk of like centralization that 4844 may bring?
My personal opinion, I don't think this is an EIP-4844 problem. This is more like a post PBS and more Danksharding problem. Just for 4844, the size we're looking at, the target is 256 kilobyte, and then the max is 512. And based on our initial benchmark, even through P2P latency and stuff like that, it's well within the scope for the home staker. And then sure, for the future, say if we move to like a 16 megabit setup, then yes, home staker may have problem, but that's where there's parallel research on decentralized block building and stuff that's also ongoing.
Thank you. So I see a question is here in the chat by user Eric. If anyone from the panel would like to respond to it. It's about, could you talk about the dissenting argument from individual ECDs or other client teams against 4844 from a hardware bandwidth full node requirement standpoint, as well as a safety liveness concern?
Yeah, sure. So like I said, right, like we have the reason why we keep going back and forth with coupling and decoupling and block and blob, Jacek raised up a concern such that we want to reduce bandwidth consumption for individual staker, low power, low bandwidth node as much as possible. And that's probably the main reason why we went on this decoupling approach. And based on the initial study that I forgot where's the link, that we do see some pretty good improvement. So I would say that the bandwidth itself is no longer a concern. And if there is a concern, the client teams are also actively looking into IP sub as well. That's one good mechanism to reduce ingress and the egress bandwidth. And I would say like the blobs are much less than the attestation bandwidth that you are getting as a node runner. So I don't think that's much of a concern. In terms of the storage, right? So we are estimating, assuming today all the blobs are full, so which is impossible, like the ETH would be burned through the roof. Assuming everything is full, it's about 3-point-something gigabyte per day. So the max of that, so the upper bound will be like 63 gigabyte per year per node. Like I said, very unlikely. And the thing about blob is it's a very different type of data than say state and block. You don't really need like a very expensive SSD for that. You can put it on a hard drive. So ideally, we'll probably give options to node operators to essentially store the blob as somewhere else. That's where they feel comfortable with, as long as you can retrieve it and serve it to your other peers.
Thank you. My next question is about the importance of KZG multi-verif function and why that is included in 4844 specs.
Yeah, so it's the batch verification allows like to slightly more efficiently verify the proofs for several blobs rather than just one blob.
Yeah, that's pretty interesting. Of course, yes. If we are trying to get it done in batch, that would be faster. I see hands raised. Vinny, please go ahead with your next question.
Hi, I guess this is more of a clarifying question. What I saw that on the slides that it said that you guys are not doing slashing for equivocation. Is that correct?
That's for blob. That's
Yeah.
that's not for block. For block, you will get slash. That's for blob, yes.
So why are you guys not slashing for signing two blobs?
Because there's economic rationality for someone not to do it. Because if today, say you send duplicated blob, you can only commit to one blob in a block. Say today, if you send duplicating blob, that the node receive the blob that you didn't commit on the block, then the node will not be able to import your block. So your block will essentially be orphaned, right? Now the question is, okay, whether there is some like DOS concern for not doing that, because of like usually when we think about equivocation, we worry about consensus, but we also worry about DOS on the P2P layer. And we don't think there is, but like I said, it still needs more thinking around that DOS topic.
Okay, thank you.
So there was this question for including the number of blobs per block. I'm curious, do we have a consensus on that? And what is the number, if there is any decided number for it?
Right now, target is 2 blobs, meaning that if you are around 2 blobs, the data guess will not change. And then the max is 4 blobs. So if you go to the max, then you have this excessive data guess field. And then it's like EIP-1559 style, essentially increase exponentially at 12.5%.
I think it should be higher than that, but yeah, that's a debate to be had.
That's a fun debate, yes.
Interesting. All right. My next question is about SSD. You did mention that some of the specs are like the blob transaction executed are written in SSD, and currently ELs do not have it. How important do you see to have SSD on EL before the implementation of this proposal, or maybe before the Dencun upgrade?
I can't speak on the EL, but I'm kind of like a schedule maximalist. I kind of prefer to keep it at the safest, but also the most timely timeline per se, right? So if revamping the entire EL stack to SSD will take longer, which I think it will, then I kind of prefer just get the minimalist done. But like I said, I have a very little knowledge on the EL, so I shouldn't be speaking for the for those guys. Yeah, what do you think, Justin, or anyone that's working on the EL side?
Sorry, could you repeat that question?
The question is that there's two schools of thought. There's one school of thought is that for 4844, we implement whatever is needed on the EL side for SSD and then ship 4844. The other school of thought is just revamp everything on the EL side to using SSD, then go from there.
That's what I was trying to trick you into answering earlier. Personally, and I know there's some other EL folks on the call too, I'll let them weigh in. I'm an iteration guy. So I like to make something small, ship it, get it out there, learn from it, and keep doing it. However, I appreciate there's a lot of people that take the other argument, which is like, look, this isn't an enterprise, this isn't a product from the Silicon Valley sense. Like, take your time, design it. You can iterate on your test nets, you can iterate in dev, and then ship it all at once. So I see both sides of it, but the amount of work involved, I would rather get something out there with 4844 that was minimal and then iterate on it.
That make a lot of sense. So we can safely assume that there could be a minimal implementation of SSD on EL clients before Dencun, or maybe at the time parallelly. All right. My next question is also related to this ELCL. I think 4844, that is a one-of-a-kind proposal that is going to affect both layers. So as a quick note, can you maybe on high level mention what are the explicit changes on execution layer and on the consensus layer that are being introduced with this proposal?
Sure. So the biggest change is that we're adding blobs, right? And then, so by adding blobs, we also need to verify blobs. And then to verify blobs, there's like consensus rules. You checking the slots, you checking the block root, blah, blah, blah. But the biggest one is this, we're introducing a new crypto library, for example, for the KZG stuff that allows us to batch verify. Like you said earlier, it allows us to, I'm not sure what the right vocabulary is, but like convert blobs into KZG commitment and stuff like that. So I personally, to me, that's the biggest change as well. That's the biggest, luckily, I'm not the one that's doing most of the work. I'm using like, there's multiple like very smart people behind me that's working on the crypto library side. So definitely makes the client team's life much easier. But as a client team, I would say consensus layer client team, the biggest change are on the networking stack. Since we have decoupled the blobs with the block, so now we have 4 gossip subnet for blobs, because there's max 4 blobs per block. And then that's pretty tricky in terms of just like, how do you optimize your beacon node and validator setup to ensure that you can either receive block and blob, also gossip block and blob at the most timely fashion. Because what we don't want is that we don't want block to be orphaned, and it's pretty easy to orphan block if today there is a missing blob somewhere at some gossip subnet that you just didn't get, and then you forget to request it, or your peer just ignore you, right? So to me, that seems like the trickiest part that we have been thinking a lot on. Yeah, I think on the EL side, there's probably the tricky part is more like an EL mempool design, which. Like I said, I mostly spend my time on the CL. I can't really speak on them.
Not a problem. One question that is on the longevity of the blobs. We are having it for 18 days. So what is the reason that we are going with 18 days specifically?
It just so if we don't do 18 days, right, then the question is, do we keep it forever, or do we have a duration that is longer, right? If you keep it forever, then it becomes another cold data scenario, which you'll be slightly more expensive, which is what we don't want, right? And then now the question is, okay, what is the duration you want, right? So we look at who are the consumers for blobs are. The biggest consumers are layer 2s, okay? So why do layer 2, how long, so the question is, how long do layer 2 needs the blob for their job function to work? So layer 2 uses to essentially submit, post their compressed batches data on the chain. That's for optimism. I'm talking about for optimistic rollup. That's for challenging. Is essentially if there's a dispute, then people can challenge enter this dispute game. And then as currently the dispute game, the challenge duration is set to 7 days. So the logic is that it would be very nice to have it for 7 days in a way, right? So then we come down to 18 days where it's like a pretty good trade-off. It's like 50 gigabyte max per year, but there's long enough for layer 2 to play out their challenge game.
Interesting. And another question is about from the same slide of Blob and blobs. You did mention about EVM access, and there is no EVM access for blobs. Do you see any downside of that? I mean, like, are we making any trade-off by not having it over there?
No, like I think it's, if we design for layer 2, that's the perfect layer 2 use case, right? But it all depends on who is using it for, right? Wonder if anyone has any input on that.
Yeah, I think obviously it makes things more complicated for layer 2. They need additional infrastructure to index blobs and resolve the transaction hashes to like the blob pre-image, but they have the resources. I think the assumption is the people who have the resources to use the blob market will have the resources to build their own custom infrastructure to leverage it without needing to access it through a smart contract. That
makes sense. All right. My next question is about the preparation. So we understand that this is not the complete sharding, and it suggests that the proposal suggests that EIP-4844 prepare Ethereum for full Danksharding. Can you briefly talk about it, like where we are and how it is leading towards full Danksharding?
So Dankrad pointing out, right, the cryptography library is there, so that it's nice. We can use that for. So we just need to apply erasure coding on top of it. That's one thing we're not doing with 4844, which we could do in the future if we want to, right? And then the whole notion of is data available, that is there. That's also black box, right? If the data is there, you can proceed into your state transition. If the data is not there, you cannot do anything. So that whole notion is nice. So I would say like 4844 set up a really, really good footing like for Danksharding. A lot of people actually don't talk about this. I do think it's really good to apply Danksharding, data availability sampling network, on top of a 4844 gossip net. So imagine you have your 4844, you have your blobs, everything's gossip, but you apply, you make this another type of node. It's not like a beacon node, but it's like a data availability sampling node that basically saves all the blobs, and then it does like, it can like does all the data availability sampling stuff on there, such as like erasure coding, such as like constructing missing columns and rows and stuff like that. That's another thing that's like very powerful to do. I think shortly after 4844, that's something to look into.
Interesting. And I don't know at this point when we are 3 or 4 DevNet past, making changes before the upgrade is like how comfortable does client teams are with that. But yeah, that's interesting to know. In the slide, I could see 5 DevNets, mention of 5 DevNets. Probably we are in DevNet 4 and we'll be going into DevNet 5. Do you think there is need of further more DevNets, or is there a plan to move towards kind of public testnet like we have it for Zishan, for Chapela, and yeah, where we are?
Yeah, I think the terminology between DevNet and testnet are pretty blurry. I think they're all the same to me, right? I think like, to me, like testnet maybe meant that, okay, like some other people can try it, versus DevNet seems more internal. And I think, yeah, if DevNet 5 goes well, I don't see why we wouldn't do a testnet. I think like what we really do want is more like inputs from the layer 2 teams, right? Because it's useless if we're just doing this by ourselves. So on our backend, I'm also pushing Arbitrum to start like implementing Nitro, for example. So once we have that 5 states go well, we can apply Arbitrum technology on top of that. And we can have our Arbitrum DevNet that's Arbitrum testnet that's on top of EIP-4844 that is using EIP-4844 and start testing that.
That is good. So we are very close to public testnet. Yeah, I mean, obviously, DevNet means it is like by DevNet, people assume it is only for client developers to maybe take a look into. And when we want to have it for layer 2, it's a good idea to engage layer 2 projects sooner rather than later. My next question is also related to testnet, but I am not sure. And that's why I'm wondering, do we see Dencun or probably 4844 on Goerli testnet?
Depends how long we're gonna keep the Goerli testnet. Isn't there talks to like shut it down? I'm not sure.
Yeah, I mean, obviously we are planning to have another testnet, but my guess is that its launch is somewhere in September, but I wasn't sure that if we are going to continue Goerli for Dencun as well.
Yeah, I'm not so sure either. I mean, it wouldn't be hard to hard fork it to Dencun. It's at the end of the day, it's a community decision. There's 12 other client teams other than us. So yeah. Well,
I was trying to reach out to my next question, which would be like, when can we expect 4844 on mainnet? Basically, when Dencun?
Spicy question. All right, so I would say that it will be very surprising to me if we don't have it by the end of the year. It would be very surprising to me, but I don't know when before the end of the year. Like I said, right, there's 12 other client teams and stuff like that. If today is based on Prysm and some other client team, that may be faster but at the end of the day, right, Ethereum, our superpower is that we have multiple client implementations. But unfortunately, there is the trade-off that like it takes slightly longer because of testing, because of bugs and stuff like that. But what do you guys think? There's other teams, client teams on the call, so I'm curious if anyone has a different timeline.
I think we want 2 hard forks a year, right?
Yeah.
Okay, yeah. I mean, by this answer, like we can expect it in 2023. That could be a guess on a broader level, but that does not answer my previous question, whether it will be Goerli or whether it will be Hollands. So we'll look whenever it is planned. A few last questions I want to quickly touch on because this proposal is actually touching both layers. So obviously you are interacting with both teams. Anything specific, any challenges, issue, or any success story that you would like to share with us?
Well, I think like 4844 is cool for me per se, because it was an initiative that was not provided, it was not like driven by say like Vitalik, right? It was the initiative was started say let's eat Denver, like Porto Landa, Donker, and like client and like. So it was a very like an organic idea. They just came to fruition, and even though there was the merge, there was withdrawal, but people were still working on it on the back end. So therefore, the train has always been moving. It's not like we're working on 4844. We just started working on it. Right? We've been working on it for over a year. So to me, I thought that was really cool to have like parallel momentum, even though you're very busy on one thing, but there's other people that's pushing the other effort forward. So with that, I do think like it's reasonable to think that's how we can have multiple hard forks for a year. But yeah, I don't have much input to say other than that.
I also want to jump in and say I've been working with Marius and Peter and Felix on the GEF team on sharing a SSE code generation library. And so that's been really nice side benefit of the layers, I think, working together a little bit more on this fork, that we're actually getting to kind of collaborate across layer teams a little bit. So shout out to Marius, Peter, and Felix for their contributions.
Thank you so much. I can understand the interaction started with the merge only, but it is always interesting to learn more about it. Winnie, I see there is another question that you would like to go ahead with.
Yeah, thanks. Also, like, thank you for all the work that you guys are doing. It's wonderful. I just I wonder if there's like any sort of rough discussion about sort of the priority for Ethereum's roadmap. Like, is after 4844, is the priority going to be PPS, or is it going to be full Danksharding, or what's yeah?
Yeah, I don't know. Honestly, like I think my personal view is more like a reactive approach, depends on what is needed at the moment, right? For example, if MEV becomes bad, then maybe we want single slot finality, maybe we want secret single data election. If today the state growth becomes unbearable, then we can focus on virtual tree and stuff like that. But a lot of the good thing is that lots of these efforts can happen in parallel in a way, right? So it's like, I mean, there's like so many people working on this research area right now, and just like, yeah, I think when we're ready to deploy something, we should be fairly close to deploy it versus minus some testing time. But yeah, I'm curious to if anyone on the call has inputs on this.
Last week, we had a chat with Alex Stokes on MEV Boost, and he obviously shared some of the upcoming roadmap for PBS. We don't know about the timeline as yet, but it would be interesting watch for people who want to probably learn about PBS and MEV Boost. All right. My last question to you is about the EIP process. I mean, it can be for anyone. I really literally checked the proposal and I don't see the name as an author, so I'm not sure how much pull request effort you have put in. But any thoughts on the current EIP process, anything that you would like us to improve?
I cannot say much because I'm mostly on the CL, and likely CL doesn't really do EIP. We have the wonderful pull request and consensus layer spec, which I mostly operate on. I know EL people does more EIP. I mean, I am a reader of EIP. I like reading it, but I don't really work on them. So, but yeah, anyone feel free to jump in.
Well, hopefully we will have a unified process for both EL and CL, and that's why we are trying to collect all these input from the process. It's good to know that you are at least reading EIP, so we can have the structure of EIPs alive if that's helpful for people. All right, it's time to wrap up. Any final comment or thought that you would like to share with the community? Any message to the community?
Let's see. I just wanna I know me and Kasey are here presenting, answering questions, but there's in fact, literally hundreds of people that's working on EIP-4844. It is probably the most important thing that we should address as Ethereum as of today, right? And then I'm really happy to see everyone is working on it, and shout out to them as well. And then, yeah, if you're interested to contribute, there's many ways. You can join the Ethereum Discord R&D. There's a channel there, EIP-4844 testing. And there's also the bi-weekly implementers call, EIP-4844. Team Bako is running that. So yeah, we're always looking for help. And then as a layer 2, I think don't wait until the end. Now is the best time to jump in, right? Provide your feedback on gas mechanism and stuff like that. And yeah, the sooner we can answering those questions, the better.
Thank you, Terence and Kasey. We really appreciate you taking out time to provide an overview of EIP-4844. I feel like it's a revolutionary proposal for Ethereum blockchain. We look forward to follow the progress and ultimately seeing the proposal on mainnet with Dencun upgrade. Dankrad, Justin, Winnie, and others, thank you for joining us for question and answer. I hope this is going to be helpful for our listeners. On this note, thanks to all our YouTube viewers and ECH podcast listeners for following this special episode on Dencun Upgrade. Don't forget to like and subscribe ETHCatHerders channel. Should you have any question on this or any other topic, let us know at ETHCatHerders Discord. Next week, we'll be back with another interesting talk. Till then, keep sharing your love with Ethereum Cat Herders. Cheers.